Yo, welcome to my channel. This is a boiler that I've built a little bit from scratch. I wanted to do some wood heating, and yeah, I've did that stuff in the past a few times, but not integrated it in my own heating system in my house. So yeah, I've saw it a few times before. We sell bigger systems like that, but they're automated and they have their own circuit boards and shit. And yeah, it's like so expensive that it costs more than a Porsche. So I want to have the same, but for at least 1/10 of the money, or maybe 100 of the money. Because yeah, this is really cheap if you do it yourself. But you have to keep in mind that some of the materials are really pricey. I got some things for free. I got some things from my office, from my shop, and yeah. So I built this by myself. This is a really old wood stove. I got it when I bought a house. It's already here. It's a cheap ass thing. It has some really thin sheet metal, so it's not that great. It's like a cheap thing, and it has some problems. It's not sealing really great, and the door handle gets really hot and shit like that. It's not great. So I've used it for like 4 years now, and it did work really great. I've had some extra air power to push some more air through the stove, so get some more heating out of it. But the problem is that I'm renting a place up there, and I want to heat that too. So I've got a Honeywell Evo, and the problem was I had to get this running on that machine. So that was a little bit of a hassle. So I built some electronics and some relays and shit, and I think it works really great. It says maximum temperature, but I'm not using it as a maximum temperature. It's like this sensor. When I go to bed and the fire dies down, there are some smoldering pieces down there. If you turn the pump off, it's gonna boil. I tried it yesterday, and the gauge went all the way to 100 degrees. So I was like, I gotta figure that out, because that's not gonna work. So I put this sensor thing. It's mechanical, so it clicks at 50-ish degrees, but it has a temperature difference because it uses contact, so it's not that great. I think if this heats up to 70 degrees, it'll trip, and then it goes to max, and when it goes to max, it'll turn on the pump. So I can turn on the pump with the manual switch, or I can turn it on with the relay. You want to have a mechanical switch, because if the relay goes kaput or goes into flames or something, you always have your pump switch for the boiler itself. It's really important that you have some safety shit. CV stands for central heating. We call that centrale verwarming. Hey, Holland, jongen. And this is the buffer. When this lights up, that means that I have actual heating requests from the Evo home. Oh my god, almost stepped on the cat again. So when I'm turning this one for heating, this is a version 2, by the way. So it's a really old piece of kit, but it does work really well. If you know how it works, it's great. It's a nice system though, but you have to get acquainted with it. Okay, so turn it on. I'm just gonna wait a few seconds, and then the relays in the basement will kick in, and then they turn on everything, and it'll work. Finally it turned on. It took like 3 minutes or something. So now you can see that there is some heating request. The buffer is on, so I got a huge ass buffer down below where that hole is. We're gonna check that out in a minute, so let's go down there. By the way, this is getting freaking hot. Yeah, boy! So yeah, welcome to my basement. This is one part of the house that contains the heating system. It contains the boiler and shit, and had some expansion vessel. And this is what I call the green energy. You know, this is the buffer. So if I'm gonna show it to you. This is the output of the wood stove. So this is going through this small buffer. It has a pipe that goes into here, and then this one has a pipe that goes into here. So I want to have a little bit of mass in this installation, because it can go like this via this pipe. It has a release valve. I don't have any safeties yet, but I've ordered one, so it'll take maybe 1 week to get here. There's a three-way valve with a mechanical actuator. I want to have it mechanical because, yeah, I'm not so fond of electronics. And I've seen it with a customer. He had a electronic valve and it went like all the way open, all the way closed, all the way open, all the way closed, all the way open, all the way closed. So the temperature went like 60 degrees, 20 degrees, 60 degrees, 20 degrees. So I don't want that. I just want to have some nice flowing, nice gentle, hey, you know what I mean. So I can bypass it right here. So when the temperature in this system, in the primary system, the wood stove isn't enough, it goes all the way through. It goes there. It goes back into. Whoop. It goes. Here's a pump, by the way. I was scared that that's gonna leak, but so it goes back into the wood boiler, and it goes back in the small buffer again, and it goes back. When the heating is sufficient, so when this pipe is hitting like 50 degrees, it's set to 50, it starts to put it into the main buffer. This one is 200 liters. I've got an extra pump. That one is gonna do the central heating, which is this pipe. So when the buffer reaches like 60 degrees, I can show it to you. This is like, now it's cold. It's like it still has heating, so it's going into the boiler right now. And now the buffer is on, and this pump will go on when the central heating system needs energy, needs heat and hotness and everything you want. Okay? Yes. So really simple. I just draw like the heat. I just draw it from the tank. I draw it back to here. There is a magnetic debris filter, which is really damn nice. It's not the one that I would prefer because it has the magnets on the outside, and I don't like when magnets are on the outside. I want to have like a magnet right in there. But I couldn't find one, so that sucks. Then the pipes go right into there in the main heating system. I've got a... Where is it? Oh, there it is! Woo! Yeah, boy! This is a return valve, a no return valve, so water can go only that way, because when this pump is on, it wants to force like fluid that way, and it wants to go like that way and back again. So I have a return valve here. And that return valve will make sure that no water is going up the boiler and back again to the buffer. I got one also here for the same reason. When that one kicks in, I don't want to have heating into this boiler because, yeah, that's like not efficient at all. And I've got one return valve in here. This return valve is really important because it's for the safety system. This is going to contain some sort of a valve which will react on temperature. When this hits about 100 degrees, it'll gonna inject cold water into here. But the problem is, if you're gonna put it in here, it's going to seek the expansion vessel. So it's going all the way back to here, because if you're gonna fill the system up, you're gonna fill this one up. So I put a return valve here. So when water is pushed in here, it wants to go there, but it can't. So it has to go all the way through the heat exchanger in the wood boiler, and it has to come back. So yeah, then it's gonna get cooled again. Oh, it's gonna pump. So now the pump is running. I don't know why the pump is running. That one should go on too, but something's going wrong, I think. Yeah, anyways, the pump is situated at the return of the boiler. I'm gonna take this off. You want to press the water through the heat exchanger. You want to have extra pressure on it because you don't want it to boil. Those systems can boil really fast, and everything above like 85 degrees will give some boiling, and boiling will give some we call it calcium buildup in the line. So there it is. It took a while because I made those two simultaneously connect. That's really nice. That's one of the advantages of the Evo Home system. So this is just a relay. You know, I can send it with a home thermostat. I'm gonna say I wanna run this boiler and I wanna run the pump. So the pump is running. The thing is running. This is hot. I'm hot. Yeah, boy. So yeah, this is my system. It's really straightforward, I think, but it really needs some things. It really needs that to get some mass, because you don't want to just put the line all the way up to the boiler, because when hot water comes past the sensor, the mechanical thing just says, hey, wait a minute, it's way too hot. So it's gonna push water through here. You're gonna get a lot of cold water back up the return, and you get like a pendulum thing with your heating, and that's something you don't want. It has to come up through a certain temperature and it has to stay there. Back with the boiler again, or the boiler or the heating system, however you want to call it, I don't care. Yeah, you want to have some really nice stable temperature, because you have to worry about condensation inside of the wood stove, because fire is wet. You maybe don't recognize it as wet, but if I cold start this thing, it'll just it'll be wet. You know, you can see the droplets on the pipes that I made. So these pipes are in the fire, and drops will just let off with it. You know, it's really gonna get wet. So you really want to have it really fast into the 40 degrees Celsius range. Maybe a little bit above, because that's just how you do it. So I set the thermostat on the boiler to maybe 45 to 50 degrees Celsius. When it goes below that temperature, it's gonna shut down, and the gas boiler is gonna consume gas, and it's gonna cost me money again and shit like that. But that's how it works, you know. I want to have a fail-safe system. It needs to work every time when I use it. So I think this works really great. If you build it yourself, or buy a wood stove, wood boiler type of thing, you really want to have a good one, not just one cheapy ass thing as I have done. This is just for testing purposes only. I'm gonna replace it in a few months. I'm gonna first test it out, and when it works really great, when the rest of the installation works really great, I'm just gonna replace the complete boiler and put a new one in. But they're really expensive. They're like 2,500 euros, maybe to 3,000 euros. Oh, by the way, the rest of the installation that I've built, with all this and what's down below, it was around 1,000 euros. Without the green boiler. The green boiler is like 1,500 at least if you want to buy it brand new. So you have to take that in consideration. But you really need that. Without the boiler, it's like committing suicide. If this blows up in your face, you're gonna die. So be careful with wood boilers and stuff, because you cannot turn off this fire. When this runs, it keeps running and it doesn't shut off. So when my light turns off right now, if I have no electricity, my pump doesn't run, and then I'm fucked, because it's gonna steam. Oh my god, I don't want to be near that. So leave a comment if you want. Don't comment if you want. Don't like it. I don't care what you want. This is my boiler. I made it how I wanted to made it. Oh my god. I'm getting drunk. I'm drinking beer, you know. Desperados. Oh my god. I deserve a beer because I work really hard on this and it works, so I'm really happy. Bye bye, take care, and yeah boy.